Hello, this is the AP Calculus 2.6C Homework Solutions. We're on page 146 in your book. I'm going to work through 28, 30, 31, and 43. And then I'm going to give you a bonus. We'll call it 30B and let you try to work that out. It's an angle related rates problem, just to give you a little more practice on that, and then I'll do the solution for that one. So let's start with number 28. Okay, so take a quick look at that in the book. We have this figure here, figure 28. A boat is being pulled into a dock by means of a winch 12 feet above the deck of the boat. The winch pulls in rope at a rate of 4 feet per second. Determine the speed of the boat when there are 13 feet of rope out, and what happens to the speed as it gets closer to the dock. I'm not really worried so much about that second part. It does get faster. So let's draw our triangle here. So we have 4 feet per second. I'm going to call this R for rope. We know that we have a fixed distance of 12 feet here. And I'm going to call the base of the triangle X. All right, so what we want is determine the speed of the boat. So the boat is traveling this way, right? So I want dx dt. What I know is that dr dt is equal to 4 feet per second. Now, you could put that as negative 4 feet per second, and I would be fine with that. I really don't care about the signs unless it's an angle problem. Okay, so if it's an angle problem, I do care if you show whether the angle is getting bigger or smaller based on a positive or negative sign. But if it's not an angle problem, I don't really care either way, since it's not physics class. All right, and we're going to relate, this is a right triangle, so I would have r squared is equal to x squared plus 12 squared. And I'm going to differentiate that with respect to t, so we'd have 2r dr dt is equal to 2x dx dt, and the constant, the derivative is 0. We want to know dx dt, so solving for dx dt, I'm going to bring that 2x underneath. The 2's will cancel, and you have r dr dt over x. Okay, so we know at the time of interest that the triangle r is 13 feet. So if you use the Pythagorean theorem, we have a 12, 13, this is going to be 5. All right, so feel free to put that in the Pythagorean theorem, but that's what it'll be. It's one of the famous integer triangles. So r is 13, dr dt is 4, and then x is 5. All right, so 13 times 4 over 5 will give you 10.4 feet per second. If you're not sure on the unit, just put the units in as we go, and they'll cancel out 2 feet per second. Okay, that one's not too bad. Hope you didn't think it was too bad. Number 30. So we have this figure right here. It says an airplane is flying at an altitude of 6 miles, passes directly over a radar antenna. when the plane is 10 miles away, the radar detects that the distance s is changing at a rate of 240 miles per hour. What's the speed of the plane? So let's draw out a triangle. So I'm going to call this, the book calls it x, so we'll call it x. We want to know the speed of the plane, which is dx dt. And of course the plane is traveling this way. So we want to know that speed. This is s, this is 6, and we're also given that ds dt is equal to 240 miles per hour. So the change in the hypotenuse there is 240 miles an hour. Of course, it's getting longer, right? So what we want to get the speed of the plane is dx dt. What we know is that ds dt is equal to 240. And once again, this is a right triangle. So we have s squared is equal to x squared plus 6 squared. Taking the derivative of that with respect to t, we'd have 2s ds dt is equal to 2x dx dt. So dx dt, the 2's will cancel, and we're going to bring that x underneath, so it's s ds dt over x. So s, it said that s at the time of interest is 10. So using the Pythagorean theorem, you'll see that x is equal to 8. So we would have 10 times 240 over 8. All right, and that is 300 miles per hour. So pretty cool that we can figure out the speed of the plane with that information. All right, so let's move on to number 31. It's a baseball problem, which is another Pythagorean theorem. So you're getting a lot of Pythagorean theorem practice. All right, let me bring that into view. It says a baseball diamond has the shape of a square with sides 90 feet. Player running from second base to third base at a speed of 28 feet per second is 30 feet from third base. At what rate is the player's distance s changing from home plate? Okay, don't really have to draw the whole diamond, but I'm going to go ahead and do that. Okay, so the player is 30 feet. So we're calling that S. That is 90 feet. The player's 30 feet. I'm going to call that X. So it's this right triangle that we're concerned about. So what we want is ds dt. What we know is the player's speed is 28, right? 28 feet per second. So we know that dx dt and we're going to relate, and we would have s squared is equal to x squared plus 90 squared. And we're going to take the derivative of that with respect to time. So 2s ds dt is equal to 2x dx dt. Solving for ds dt, the 2's again will cancel. So ds dt is equal to x dx dt over s. So x, we know it told us in the problem it's 30. So I've got this triangle here. We know this is 30 and this is 90. So s is going to be the square root. S is the hypotenuse, right, of 90 squared plus 30 squared. All right, so when you put that in your calculator, you get 94.9 feet. Okay, so ds dt would be 30 times 28 over 94.9. All right, and that is 8.85 feet per second. If you got negative 8.85 because that distance is getting shorter, that is totally fine. I would count that correct. That would be more correct from a physics standpoint. But I'm also fine. Again, I'm only really worried about do you get the sign correct when there's an angle involved. Okay, so now let's get to one of those angle questions, number 43. Okay, here we go. We've got an airplane flies at an altitude of 5 miles, so that would be the height there, toward a point directly over an observer. The speed of the plane is 600 miles an hour. Find the rate at which the angle of elevation theta is changing when the angle is 30 degrees. So we're just doing part A here. Okay, drawing out this triangle. You know, it's a right triangle. This is theta. And we know this is 5. And we want to know the d theta dt. So the plane, we'll call this x, is moving this way at 600 miles per hour. And we're probably going to need a letter for the hypotenuse, so I'm just going to call that h. We know then the plane is moving in the x direction. If you labeled that a different letter than x, then it would be that letter. But dx dt is equal to, now theta we know if the plane is moving this way and this hypotenuse is going like this and moving that way, theta is going to be getting bigger. So I need a positive final answer. Since the hypotenuse will be getting shorter as the plane moves this way, I'm going to say that the hypotenuse, or that dx dt, is a negative 600 miles an hour. If that gives me a negative answer in the end, then I'll come back and change that to a positive. But I believe that's going to work. So we're going to relate. And what you relate, the trigonometric function that you use is the one where you know the rate, that would be x, we know the rate in x, and the fixed side. So with theta, we have the adjacent side and the opposite side, so we would be using tangent. So tangent theta is equal to 5 over x. I'm going to change that to tangent theta equals 5x to the minus 1. Take the derivative, you'd have secant squared theta, d theta dt, is equal to minus 5x to the minus 2 dx dt. All right, so solving for d theta dt, it's going to be -5, stays on top. Then we have dx dt over secant theta, and I'm going to write it like this, all squared, because that's what that squared means, times x squared. Okay, so we need some sides now. All right, so it says theta is 30 degrees. So I'm going to need to get both x and h because secant is hypotenuse over adjacent. So we would have the sine of theta. So the sine of 30 degrees is equal to 5 over h. So h is equal to 5 over sine 30. Sine 30 is a half. So h is going to be 10 at the time we're interested in. Okay, so that hypotenuse is 10. We also need to get x. Well, we could use the Pythagorean theorem now that we know. So we could say 10 squared is equal to x squared plus 5 squared. And if you go through that, x is 8.66. You could also say tangent 30 degrees is 5 over x and solve it that way. Either way is fine. So I have -5. dx dt is -600. Secant is hypotenuse 10 over adjacent 8.66. We have to square that. Times x is 8.66. We have to square that. So this is kind of nice because you have an 8.66 squared and an 8.66 squared. Those two actually cancel. You can put it in your calculator, but they cancel, and you end up with 5 times 600 is 3,000. And only the 10 squared is left, so that's 100. And so that's going to be 30 radians, and the time is in hours. Remember, that's 600 miles an hour. So 30 radians per hour is positive because theta is getting bigger. So I picked right when I said negative. If I'd say positive, then we would have gotten -30 radians per hour, but you could go back and just fix that. All right, so I'm going to do one bonus problem here with an angle, but I want you to try it first. We're going to go back to number 30. So flip back over to number 30. We're going to call this 30B. And the question I want to ask, if you read through that, the only difference, we're going to use all the same information, but the question is, at what rate is theta changing? And we're going to redraw this triangle and show you what I'm talking about with theta. So we have theta is here. Okay, so we know this is 6, this is x, and this is s. Okay, and so we're going to do everything the same. S is 10. All right, the plane, this is changing at, so we know that ds dt is 240 miles an hour. That doesn't change. We know that s is 10. This is 6. I just want to find what rate is theta changing. So go ahead and pause the video and try to do this, and then come back and we'll show you the solution. Okay, here's the solution to this. Just give you a little more practice. What we want is d theta dt. We know that ds dt is 240. Now we're going to relate. So what trig function will we use? Well, we know the rate on S, and we know this side. So we have the adjacent side and the hypotenuse side. So that would be cosine. Cosine theta is equal to 6 over S. So cosine theta is equal to 6s to the minus 1. And we're going to take the derivative with respect to time. So it would be minus sine theta d theta dt is equal to minus 6s to the minus 2 ds dt. So solving for d theta dt, I would have minus 6 on top, ds dt, I know that one, over negative sine theta, so those negative signs are going to cancel, times s squared. Now this theta, since the plane is moving that way, that's a terrible arrow, I'm sorry. I'm trying not to erase anything, so there we go. We know theta is getting bigger, so it should end up being positive. Okay, so we have 6 times 240. Okay, sine is opposite x over hypotenuse. We know this is 10, and we know that the x side is equal to 8. That's a 6, 8, 10 triangle. Use Pythagorean theorem if you don't remember those ratios. So it's going to be sine is x over s, opposite over hypotenuse. So 8 over 10. And then s was 10 squared. So that's a 6 times 240. Oops. Which is 1440. And then 0.8 times 100 would be 80. So that is 18 radians per hour. Not radians per second. That would be the thing spinning, 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 spinning super fast. All right, it's radians per hour. Okay, so I hope you got that right. If not, I hope it helped you to get to work on another one. Let's talk about the quiz. So the quiz is is 50 points. There are 5 questions, and they are 10 points each. Okay, I would, the only formulas that you'll really need to know, you need to know the Pythagorean theorem. You need to know the area of a circle. Maybe the circumference of a circle. The easy formulas. All right, I expect you to know area of a triangle. You need to know your trig functions. So you need to remember, that sine. You need to know SOHCAHTOA. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And if you end up with secant or cosecant or anything like that, you just flip them. All right, anything else, any other formulas you will be given. So you don't need to memorize the formula for the volume of a cone. The basic ones, area of a rectangle, goodness, I would expect you to know that. Or a triangle, 1/2 base times height, right? But if it's a cone or a sphere, we worked cone and sphere problems, stuff like that, I'd give you those. What I would do to study for this is just rework all homework problems if you have time. If there's any way you can do it, take the time to rework all the homework problems. And setting up the problem, correctly. So if setting up the want, you got to show all that. Know, relate. That's a big portion. That's at least half of the partial credit. So if you know what you want from reading the problem, and then write down what you know correctly from the problem, and write down the correct equation. If you mess up on the derivative or mess up on the plugging in, that's one thing, but setting it up will get you correctly, all parts will get you half credit, and then the calculus part and the plugging in part is the other half. Okay, so if you'll just rework all the homework problems, I don't think these problems are especially hard. You don't want, make sure that you get the units right. I remember having a student that missed the unit on all 5 problems, so that was -5 right there, and that's kind of a pain. Go through it, think through it so that you can get the units right. But remember, I told you on the last quiz where we just did implicit differentiation that the average on this test as a whole is 92.8. So that's really good. A lot of people make 100 on the first part, and then they'll make, they might make in the 80s or the low 90s on the second part. But when they get to average that with 100, a lot of times they end up with, a 95 because they made 100 on the first part and a 90 on the second part, And that's great. Or if you make 100 on the first part and an 85 on the second part, that averages out to, 92.5. So that's pretty much what students have been doing. So if you miss a little bit on the first part, that makes you have to do a little more on this second part. But overall, even though all 5 questions are word problems, and there's nothing on the quiz. So let me find. There's nothing on the quiz like these first 8. It's all word problems. These were just getting you used to taking derivatives with respect to t. But they are all 5 of them are word problems. So you don't have to go back and work any of these. So that'll save you some time. So rework all homework problems except 1 through 8. You don't need to worry about those. Concentrate on the all word problems. All right, so I know this video is going really long, but I think it's useful. Good luck on this test. I think that this material is actually really interesting, and these are fun. I hope you felt the same way, but even if you didn't, good luck on the test, and I will talk to you next lecture.